In our previous video, you learned what protons, neutrons, electrons, neutrinos, positrons, and photons are. If you need to repeat these definitions, please double left click on definition and study that table. We also spent some time on explaining what hydrogen 1 is and what hydrogen 2 is, helium 3 and helium 4. Left click that table to make it disappear and double left click on equation for nucleosynthesis. You need 4 hydrogen nuclei. 1, 2, 3, 4 nuclei. You need 2 electrons, and as a result you will get 4 2 helium nuclei plus 2 neutrinos plus 6 photons. And we also made it clear that this reaction, nuclear reaction, can only take place in the core of the sun at very high temperature, 16 million degrees Kelvin, and a huge amount of pressure, atmospheric pressure. Only under these conditions this nuclear fusion will occur. When looking at this reaction, you should be astounded how this is possible. Here you have 4 protons and 2 electrons, and you end up with a nucleus that consists only of 2 protons but has now 2 neutrons. So where do the neutrons come from? And then you have also 2 neutrinos. We don't have any neutrinos on the left-hand side. And then you have 6 photons. Where do these 6 photons come from? That has to be explained. So let's take out everything that is on the right-hand side of this equation reaction, and we do that by right-click on these representation here. So now they're all gone, and now please show me how you get from these particles to what we just took out. First, you have to understand what the high temperature and pressure within the core of the sun does to the protons. You know that protons have the same electric charge of +1e, and usually under normal circumstances these protons repel each other because of their electric charges. So the electric magnetic force repels them. By double left click on Fs and F question mark up here, you can get some more explanations. For instance, here the electric charges that repel the two protons. But what happens now in the core of the sun at this very high temperature and pressure? The protons are moving very, very fast at very high speed, and they crash into each other. So this high temperature and high pressure overcomes the repelling force of the electric charges. And suddenly a new force comes out, which is called the strong force, that is 17 times faster than the electric force, that holds these two protons together. And they have to get very, very close together. The range is 10 minus 15 meter. Now something really dramatic happens. When these protons crash into each other, suddenly one of the protons transforms itself into a neutron, a neutrino, and a positron. And we know that an element that has a proton and a neutron in its nucleus is hydrogen 2. Let's do the same thing with the two other protons. Because of the high temperature, they are pushed very close together. The strong force becomes effective, overwhelming the weaker electric force, and one of the proton transforms itself into a neutron and a neutrino, and we have another hydrogen 2 at nucleus. Now something really dramatic happens. The positron and the electron, which are nearly identical particles except that one has a positive charge and the other has a negative charge, they crash into each other and annihilate each other. Their masses totally disappear and they turn themselves into energy. I do this here by double clicking, and this energy is in the form of photons. If you don't remember photon, double left click on photon down here, and a photon is a light particle with an energy quantum, and the symbol is gamma and it has no mass. We have talked about that before. Now let's do this annihilation again. Annihilation of a proton, of a positron and an electron. We crash them into each other and they transform themselves into two photons. Now these hydrogen 2 crash into each other. These two hydrogen 2 nuclei crash into each other, and we leave out a little detail here, but it doesn't really matter, and they fuse into a hydrogen and into a helium-4 atom. And while they are doing that, more energy is released in the form of, and I got one too many, photons. Now you see what we have. On the right hand side we have one helium 4, we have 2 neutrinos, and we have 6 photons. I will do this reaction one more time slowly. So you can right click on each of these symbols, and we start out with 4 hydrogen, we add to this 2 electrons. Of course, we have the high temperature in the sun, 16 million degrees Kelvin. That's about the same as in Fahrenheit. Very, very hot and very, very high pressure. This pushes the 2 protons together and overcoming the repellent force of the electromagnetic charges, and one of the protons transforms itself into a neutron, a neutrino, and a positron. That happens twice. Then one of the positrons and one of the electrons annihilate each other, and this annihilation leads to two photons, which has no mass but energy. This happens the same thing with the other pair of positron and electron. We get another two. The next step is that these two nuclei fuse together into helium-4, and that releases more energy. So, and here, this is all we need to know about the sun's nucleosynthesis in this introduction. Please do now the following. Think about the masses on both sides of this nuclear physical equation. You have mass of 1 proton, 2 protons, 3 protons, 4 protons. In addition, you have the mass of 2 electrons. And you end up with a mass of a helium-4 nuclei. You also end up with 2 neutrinos, which also have mass, and you end up with 6 photons that have no mass but energy. Let me repeat slowly what the question is we are aiming at. We have masses on the left side and we have masses on the right side. R is the mass on the left side of this equation larger than the masses on the right side of this equation. Please give it some thought, and I give you one hint. Think about Einstein's equals E equals mc squared.